Evening.
Hey,
Hello, hello.
Peter, good to see you. What's happening?
Uh, I'm coming to grips with RVF.
I'm doing something. I got all of a sudden I'm getting like hundreds of freaking messages every day about it. So
I'm
something's
not
going on.
surprised. Yeah,
Well,
everybody's typically obsessing about tooling to do swarm coding, and that's all very well and good, but assuming that your coding situation actually warrants a swarm, and if you're ideating while you work, it's really not that key a thing. Whereas all these modules like vector and everything else, that's extremely useful and interesting in and of itself. And I think warrants much more attention and praise than just the coding setup.
I'm sure at some point Anthropic will steal it and claim it as their own, but until then, it's ours.
Yeah, this is really incredible, the slow pace that these huge companies are moving when implementing these features. And it's not like they were rolling out Excel or Word that you have to have every little detail polished and it's huge functionality, because neither is it huge functionality nor every detail polished in what they're doing. And yet, it's big organization, lots of cash, and very slow pace of progress. I'm very, very surprised.
Yeah. I can't stream this again. I thought I'd fixed this problem on not being able to stream. I might have to create a next week. I might have to create a new version of this Zoom meeting, or maybe let's see what the heck's going on. Sorry, guys.
So, Ruben, how did you feel about the fact that I told this guy that you created RoofBot with OpenClaw?
What's that? I'm not sure. I'm not sure. Tell me more.
I said I told that guy on LinkedIn that you created RoofBot with OpenClaw because he asked.
Oh yeah, sure. Yeah, that's fine. Um, there's a new one that came out today. What the heck was it called? I forget what the hell it's called. I get too much on my mind here, but that's built all in Rust. It's even better. I created an RBF of it earlier this morning, and I don't really get the whole open claw thing, but I guess
A
people are
hype.
into it.
It's a hype. It's literally a hype. That's the why.
Yeah, it's crazy.
Mm. And you use that cognition container description for your RBF format. I like that.
Yeah, that's really useful.
Yeah. And now you need to have a meta orchestration layer where you start making your RBF containers into something like neurons, which then can become specialist in clusters and then maybe form a brain in a couple of
That's what
months.
I did. That's why I've already done that. That's exactly what I'm doing. I don't position it that way because it scares people a little bit, but that's essentially what I've done.
Okay. Then
What
you're
was
Yeah.
that? Because I didn't catch that. What have
and
you done?
and and did you actually have a look into the IICP protocol, which is about a network layer intent coordination protocol like HTTP, which did a lot of inspiration from your QDEC and how you're doing things, which might be used later to orchestrate massive homogeneous layers of different AI into a one heterogeneous layers of AI into a homogeneous AI construct, like a brain or something like neurons. Did you look into that one?
No, I haven't.
It's called IICP. Mind if I really copy fast the GitHub link with the draft for this protocol specification?
Sure.
Because it might be helpful for your endeavor. That's why I'm asking.
Yeah, for sure. Sounds
Let me
interesting.
let me paste it. It's only a draft, and it's literally something I wanted to pitch to IETF for a protocol, which might become something like the HTTP for from AI for AI inferencing, and it might become something which you can, or you might leverage it to use it to coordinate your RVFs, or even other people's cognition containers if they come if others try the same thing.
Okay. Well, that
Just
sounds
look into the
cool.
draft and then let your whole ecosystem analyze it and see if it helps you to get things done better.
Intent-based inter-agent communication protocol. Okay.
Exactly. So the idea is to build something like a torrent network later on, where people like from the Agentic Foundation or other guys who have like spare compute and inferencing power to put it into pools and say like, okay, today I don't use my stuff and I put it like for 20% into a pool, which then people can use in some kind of like a group or a team or something to help each other with inferencing. So this was the initial
You,
idea.
BitTorrent was created by a guy named Bram Cohen, which people seem to are convinced that I'm the guy. I'm not. I never created BitTorrent, but
So
a lot of people reach out to me and like, oh, I love BitTorrent. I'm like, no, that's maybe my cousin or from a long lost mother, but not me. But it's funny you mentioned BitTorrent.
yeah, but then walk in his footsteps and create bot torrent.
Well, I'm not in his footprints. I created Cloud before he created BitTorrent. He's in my footsteps.
Yeah, that
Just
would be a
saying.
metaphor, you know. So
That's
so
right. I
anyhow,
Yeah.
say, um, uh, what was it? Russell Crowe looks like me.
He's a you're a good looking man, Rob. Good looking man. And I look like Rob, so there we go.
I need something.
Question is,
Now
from
it's
which movie?
well, Gladiator. What other movie would it be?
Clearly Gladiator.
Yeah, clearly. We're not talking like washed up Russell Crowe. We're talking prime Russell Crowe here.
I'm gonna
Yeah.
lose charge. Sorry, guys.
What?
I'm gonna lose charge. Roof. My audio's down and dust. I'm on the road coming back. Just had
All
a
right, Phil, focus
hospital
on the
appointment.
road. Focus on the road. Yeah, don't want any. So I can't stream again today because I guess I hadn't fixed the problem, unfortunately. So this will be another private session for us. Not that it really matters. I can say things that probably won't be too bad then. Yeah, so Vint Cerf reached out last week. That was kind of cool. So the inventor of TCP.
Nice.
Hey, Dragon, how's it going?
Yeah, quite busy. Uh, Trying to keep up, now extending the support for Agentic QE fleet to both OpenCode and key roles. So let's see what would be the next thing to add. I think you already added codecs. That should probably work with the OpenCode part, but I need to look out, for that one.
Yeah, I got
Uh,
codecs.
yeah.
I stopped using the OAuth key thing when the OpenClaw guys killed that. So, well, you can still use it, but I wouldn't suggest using it. Where you
Mhm.
can kind of copy the keys into the RBFs and run multiple Claude codes in there. They ruined a good thing. It was such a nice feature. Oh well.
But think of the
It's that.
GitHub stars.
I can't really say anything. I've been on my GitHub. I got 1,000 GitHub stars yesterday, which is good for me. I don't not 180,000, but I'll take 1,000.
Was that on
I'll
Root
take my
Vector?
200.
Well, it's taken me a while to get these projects, but still the most popular one is still, what is it? The that
Cloudflow.
Wi-Fi decompose that still does like several hundred a day.
I think it was Cloudflow.
Oh yeah, I guess there's that one too. Yeah, that's okay. That would be the most popular, I guess. I've already moved on from that. Cloudflow's last year. I'm on to other things. I do keep it up to date, but the real interesting stuff is probably more of the root vector stuff that I'm doing. That's what I'm passionate about anyway.
Yeah, rename still in progress, so it's still, work ongoing, right? To rename
Yeah.
it to roof flow, right?
Yeah, I got to do that. I've got a major update coming to Cloudflow actually. I came up with several new GNNs and and I'm gonna integrate the RBF and all the bunch of other things into it. It's I pushed a minor update earlier this morning, fixed a bug in my GNN. I moved from layers to head. If for those
Mhm.
interested in those things. All right, one sec, guys. And Jed, good to see you. It's been a
It
couple
has
couple
been a
weeks.
moment. For everyone here, I discovered, or I stumbled upon, the reality that Anthropic and OpenAI are now offering retention offers. That is to say, if you have a long running subscription and you cancel it, they will offer you a month for free. So now I'm starting to rotate and age different accounts in an effort to receive a retention offer. So my subsidized token consumption gets subsidized further.
Oh, I love it.
Nice.
Speaking of, Martin got us a nonprofit rate on Claude Teams. Right?
Oh,
Which Martin,
wow.
yeah, I saw the email from. I know I haven't had a chance to read through it too clearly, but it looks like a what 50% discount or something.
On what, the monthly subscription or the token API subscription or
Don't know.
usage?
I don't know. I don't know if Martin's here or not, but yeah, so we got to explore that, see if we can leverage that through our crew. Let's all sign up. We're all part of the team, right?
So how does that
Way to
work in
go, Mark.
practice?
I don't know.
So everyone can
Uh,
start paying monthly dues to the Agentics Foundation and receive subsidized tokens.
well, I don't think we're allowed to do that exactly. Usually, they don't look kindly on sort of using it as a revenue generator. So we'll probably have to make it like you actually are doing work or something, and it's part of your job, if you will, with the association. But as long as we're not selling it as a perk of being a member, we're probably okay. Now that's a question for that's likely a question for Merton.
Okay.
But yeah, looks good. Looks really good. And Google's also giving out discounts and whatnot for Google Cloud. So one of my customers is a not-for-profit, and they were able to get substantial discount for their Google Cloud bill, like massively, like 80% kind of thing. So see if we can get that too. That requires
I'm
talking to
gonna
Google.
hop off and leave you guys to it. Have an awesome vibe coding, Roof.
Okay, yeah. See you soon.
Hey, buddy.
Just before we get started at the top of the hour, one thing I've been experimenting with is normalizing the chat history across Codex, Claude Code, and Open Code, and then making the chat history itself searchable. So that's allowed me to have independent agents without orchestration to effectively learn from each other. Has this problem been seen before? And
Oh,
how was it solved by someone else or another agent?
guys, I
So it's
can't
not
record.
explicit.
I'll be right back. I guess I'm logged in as the wrong user or something. Sorry about that.
I I
Technical
got it.
diffi-
I got it, Roof. I
Oh,
think
oh, you did?
should be good now.
Are you able to set up? Oh, yeah, live streaming is working. I just wasn't. Okay, here we go. I'm not particularly organized today. Sorry, guys. The live stream button wasn't available until I guess the agent or user showed up. Sorry about that. One sec. Usually it remembers the settings until I'm behind, then it forgets. Right, so we're Agentics.org. All right, so I use Restream the service to stream this stuff. Usually Zoom remembers the settings until I'm late or forget, and then it makes me enter it. All right, well, while that's getting set up, thanks everyone. We haven't done this in a few weeks because I've been traveling all around and doing various things. People want me to leave my office, I guess these days. I'm happy not leaving my office, and thank goodness I didn't have too much trouble at the American border. They only stuck me in that room for about 10 minutes, long enough to do whatever they're going to do to my phone. So that's a plus, and they were one of the first to see the RVF format. So let's see if my quantum encryption keeps. Anyway, good to see everyone, and we don't have Rob today, but I think he had to take off. But Jed, you were saying.
So what I do now, I'm getting to the point where I'm becoming model and coding agent agnostic. And one major problem is sharing knowledge or learned attributes. Now we have many different layers and solutions that are memory focused, but the problem I have with those solutions is they are centralized and it becomes a bottleneck when you have up to a dozen agents trying to learn something or recall something from that memory system. So what I've done instead is to capture the discussions as a transcript across all agents and then set up a different search platform so it scales horizontally to allow them to search each other's transcript in order to learn solutions to previously solved problems. And at least for now,
Okay.
it's allowed me to scale to multiple concurrent servers, each hosting multiple agents, communicating amongst each other in in an indirect way, sort of the same way plants communicate with pheromones, to ensure that learnings from solutions to problems persist across the entire collection of agents. I hesitate to use swarm because it implies a unity among them, and this is very intentionally ununified.
So how's
More
that?
like a mycelial network.
That's a
Yeah.
good way. Yeah,
Th-
mycelial network. That's a good way to describe it.
And how
It
does
is more
that
like
differ from like the sort of graph GNN sort of vector approach that I take, where I'm saving trajectories and optimizing that structure?
that is centralized. So
No,
my
it's
understanding,
completely decentralized.
But
I
how do you
decentralize.
maintain state if is each agent then supporting their own version of that graph?
Yeah, that's exactly what's
Or is it
happening,
a central graph?
it's a decentralized graph. So it depends. So it depends on what it needs to sort of understand. But I separate the process of learning the state, like all the information that goes in the requests and the code and the errors, and then I use reinforcement. But the important part is after the reinforcement part's done, I've learned everything I need to do. It creates a kind of internal knowledge or skill. That skill is transferable using a transfer learning. So I'm not transferring like the steps to get to the ability to learn to understand. I'm transferring the trajectories that allow it to then use those skills later that traverse both the vector space and the graph itself. And then I apply that with a GNN. The GNN
So
allows it
how
to
does
sort
the
of have
eventual
the attention.
consistency occur? How do
Well, depend.
disparate,
It
decentralized nodes synchronize that knowledge?
Well, it depends. I've got a few different approaches, but generally I use, well, for networking, I use, Quick, which uses eventual consistency on a networking layer for the handshake. Then on the sort of the consensus basis, if I have a lot of resources available to me, like a normal sort of VM, I use Raft. If I'm not if I don't have a lot of resources available to me, then I just export the deltas. The deltas allow me to basically send just the key bits of mathematics that are required that allow it to traverse that information quickly without having to send anything more than the most minimal viable component, which in this case is the delta, or that what
So how do
looks
you
like.
avoid factorial scaling? So if you have four agents with four independent vectors that are all learning from themselves, you have agent A
Are
teaching
you
to
talking about
B, C,
drift?
D. No, not drift. How do you, when you're maintaining that synchronization, I have in a pool of four agents,
Mhm.
I have agent A with its learnings. Uh, the learnings will transition to B, C, and D. So that's one set, three. I have B pushing its learnings to A, C, and D. I have C pushing its learnings to A, B, and D, and then D pushing its learnings to A, B, C. So those are, what is that, 12 connections between in a pool of four agents. So that means a pool of five agents would be even more. How do you prevent that scaling?
I'm not sure if I quite understand your question, but in the
It's
what I can show you is
It's decentralized,
what I can show you
and you
guys is how I'm doing it on my Nano, or sorry, my Zero. So back to my Zero for a moment. I can connect multiple of these together in a swarm, right? So in this case, multiple little devices that are essentially embedding root vector on this. It's basically Raspberry Pi Zero. And so I get 512 RAM, and this got a 16 gig SD card in it. So limited resources. It's got four core processor. Now, what I want to do, similar to what Jed has mentioned, hopefully I'm sharing the right screen here, is I want to share the resources, across them. So this is the dashboard for just a single device that I've connected to. Now, in this device, there's a variety of different components that I can connect to and run locally or within the browser itself. So I pair it, and then once I have that, I've also got a swarm capability. So the swarm again allows it to understand itself and some of the other available resources. Now, I don't have any other resources currently connected to this particular one because I just ran a quick on this environment. But hypothetically, let's say that let's say that I connected two of these or more. This system then it has the ability to communicate with all the other available nodes in that swarm. So in this case, the most basic here is I've got a synchronization element here. So the synchronization element again provides this, a delta pull or push, right? I'm pushing, pull or pulling depending on what's needed. Now, I'm using it in a sparse sort of setup, so it's not constantly doing it, right? It's monitoring. I don't know. It's hard to describe it, but it's monitoring the integrity of the overall system and then saying, based on certain characteristics of that system, is it outside of the bounds of the acceptable operations? Has something changed? Does something need to be pushed or pulled? At which point the system sort of wakes up, or at least that particular agent or process wakes up and then sends that or pulls that information. So in the most basic sense, these what is it, four components provide the ability for me to sort of understand who or what is available to it and then sync. So in this case, you can see here in this particular curl, it's pulling changes since a certain sort of epoch was run. So think of a GNN and learning compilation. So it doesn't have to learn all the time. It only needs to share bits and pieces that it needs to share. Now, in this case, you can see here that it's essentially returning the vector. So I'm sending purely just math, light, and the math is just the specific thing that changed in the vector store itself. So I'm not communicating it in the way that you would communicate like an LLM. I just changed 50 files, and here's an MD describing all 50 files that changed. I'm just updating the particulars in the shared vector store that the system can then understand in correlation to everything else that's happening. Now, I know it's kind of a weird concept. I'm communicating in math, right?
So
And
you
that
have this
math,
state. Is this state
yeah.
duplicated across every agent, or is there some centralized aggregator of state that all the agents consume from?
There's a centralized. It's not. Centralized is the wrong term. It's not nothing centralized. Well, I guess if I'm running one of these boxes, then it's centralized. But once I've got multiple, chips or appliances or these sensor bots, I can then sort of aggregate those in a decentralized fashion. The most obvious sort of use case for that would be like I don't know, decentralized witness, where I can have multiple untrusted devices all collaborating and learning, and one might get exploited because it has physical access. Someone takes out the SD card, pops in one that is now exploited, but it doesn't take down the whole entire system. It assumes everything has zero trust. So I'm in a position where when I don't trust anything, then I can sort of understand the nuance. So I guess it's hard. Again, I don't have the easiest way to explain it, but long story short, I expose all the components in a variety of different API calls. Now, everyone loves MCPs, and I love to pick on MCPs, but I'm essentially creating an MCP device, right? So here are all the different endpoints relating to like loading kernels or RVFs. These aren't all the capabilities. These are just the most important capabilities for sort of interacting with my system. For beyond this, use the API itself, which would have quite a bit more. So you see here like upgrade endpoints. This is the hardware that's running. And then these are the GPIO is an interesting part of this device. Back to this device for a moment. If you look, I don't know if you see my screen or my face here, but it's got a 40 pin sort of GPIO. So what this does allows me to connect sensors, right? And the sensors could be like environmental sensors, HVAC, heart monitor, or whatever I can plug into this, and then the system is able to read the data from that directly, and that can be in the form of wave, which would be like a hertz or gigahertz kind of signal, but it can also be sort of a kind of pattern-based signal, and that signal might be like your information coming from, well, the opposite of a brain scan. Maybe it might be like the information coming from, I don't know, heartbeat, possibly, like a human
So
heartbeat.
in a collection of, let's say, four Raspberry Pis, how do they synchronize their state, or is their state even synchronized? Do they all connect to each other,
They're
or is it more like
I
connect?
just showed you. It's the sync API point
Right, but
that synchronizes the state in vector,
who?
in a vector form. It's all stored in a vector. And I'm not sure how else to describe it. It's not text, if that's what you're asking.
It's not about the text part. So in my case, for just to simplify things a bit, state is a learning or a representation of a learning. Could be vector, could be text, could be image, or just straight binary. What I'm trying to understand is node A in an ABCD network learns something. How do BCD get it, or get that learning, or even need that learning, or know that they need that learning? Does that mean it's synchronized from A and then the vectors are adjusted? What about if B, C, D are individually learning separate things? Do they then synchronize back to A? Because that then implies every node would need to connect to every other node, and that becomes, well, that increases the communication overhead the more nodes you add to the network.
That might be a question for ChatGPT. I'm
I've
not really
asked it,
sure how to
and
answer.
the way I
Yeah,
solved it
so
is
so
basically everything is
let's
independent of everything else, and they commit to a shared repository or pool where while they have access to all the data, they are not explicitly querying all the data. They're querying what is adjacent to their knowledge. So the
Gotcha.
best way to describe it, I have a sandbox. There are 4 sandcastles being built, but the knowledge of the other 3 sandcastles is not fully available to the agent until they dig a moat to the corresponding castle.
So what question am I asking here? How are we handling decentralized state across multiple?
What
And I'm
to
doing this in a variety of
understand.
different ways. Multiple like agents. It's not really an agent structure.
What I'm
Multiple instances of root vector. I don't know, something like
So
that.
what I'm trying to
It's-
understand is how multiple invocations on root vector, each presumably attached to individual agents, are able to coordinate, learn, or merge, or I guess coordinate or learn from each other. Because I know it's a stated feature, I haven't been able to use it. And this is after having Claude Code and Codex going through the code base to try and identify it.
All right. Well, let's get to the bottom of it and see what we can find out. I'm not articulating myself. We'll come back to that in a minute. So one of the things I want to show you guys today, last week I was at a hackathon, and I've been playing with the RBF format. Hopefully, I'm
We're
sharing
seeing
2
two
screens.
screens, Drew.
Yeah, is it? Can you see both screens?
They're
Is it too
pixelated
small,
for me.
or does it just work for you guys?
Too small.
It's very
Too
pixelated.
small? Oh, it is? Okay, I'll come back to Jed's question in a bit. All right. In the meantime, so the RVF format is pretty cool. So what you're looking at right here, you see I'm running everything in a self-contained RVF package, including the Linux runtime, a Vite style Vite.js dashboard with Three.js running, and a self-contained vector store to basically find various forms of communication in the sort of, or not communication, planets in the solar system and galaxies and whatnot. This is basically just Three.js visualization of the system. Now, what's cool about this, again, it's self-contained. So, much like what I was showing you here on the appliance, this could run directly on, a chip or an appliance, or completely independently of a cloud-based environment. No cloud required. In this case, I embedded a small language model as well. So what that does is, first of all, is it allows me to do things like a blind test. So when I'm going and trying to find planets, these systems, as you guys are aware, can create very convincing fraud, right? Or very convincing simulations of things that look true but aren't actually, right? So in this case, what I did is I started with a blind test. Once I built the system, I then said, can I find the same things that have already been found without revealing the things that I'm looking for, right? So one of the problems you have with a language model is there's a tendency for the language model to tell you the answer because it's been trained on the data that contains the answer. Now, in this particular scenario, I'm not using a language model. I'm using purely mathematical sort of structures that underpin it. So I'm looking at a kind of vector, in this case, a quantum style vector space, to see if I can find the same planets without telling it where those planets exist. It turns out I was able to do that quite quickly. So I was in the 10 planets that were found recently. I was able to find those planets, using a blind test, with 100%. Well, according to this, 94%, but it's 10 out of 10, so that's 100% to me. So now that I have that, I'm like, okay, well, can I prove it? Second problem of language models is this idea of the witness, right? And each of the steps involved in actually finding a particular element, or in this case, a particular planet, and defining how in which that was found. So within the pipeline of steps I need to do to find these things, I need to validate and hash or cryptographically verify each of the things I needed to do to find and discover the thing. So think of like a proof. It's basically proof of work. It's a proof of work that sort of proves that each step that has happened, and in how it happened. Now, more importantly, it uses a seed because it's deterministic. That means when if I give you this RVF, which by the way you can go and run yourself, it's in the examples folder. Where the heck did I put that? Let me just make sure I remember where I put that. It's in Examples, RBF, causal atlas dashboard. So if you go into the RBF folder for a moment, you can run this yourself. And then you'll see there's an examples, and then you'll see causal, causal atlas. So this is the appliance. So you can run it again, self-contained. You can make it as an R in a RBF format. Where did I put those? Where is the RBF? Anyway, long story short, it's a self-contained file that includes all the sort of learnings, all the process. It includes the Linux kernel. In this case, I can then go and understand each part. So if I want to look at how it found a stellar parameter, and when I see the first step, RBF store opened, Genesis anchor created. Step two, it did ingested the sort of various information for a particular candidate. It did some more studying of the periodic signals, which is basically, I think, the movement of the planet as it goes behind a star and creates a slight variance in the amount of light coming off the star, I think is what it's doing. So I'm able to do that, and this is all happening in seconds, by like microseconds. So each of this is being cryptographically verified, so I can basically validate exactly what happens. I can see each step down here as well. Okay, so now I've got the system capable of telling me exactly what's happening inside of this really complex neural network, sort of vector-based system. What can I do with it? Well, let's try to find some stars. So in the world, let's try to find some planets. So in this case, then it's taking publicly available data and trying to determine what the most likely planets are in terms of both their chemistry and just viability. So you can see here that I'm looking at it and then validating the information, which is kind of cool. And there's some other detection criteria. Again, some of this is beyond my ability to explain, but essentially it's finding planets. Once you found the planets, I'm like, okay, can I find life on these planets? And I'm not necessarily looking for life that is human life. I'm not looking for what the Star Trek guys M-class planets. I'm looking for just planets that might exhibit potential life based on biosignatures, which is what I'm doing here. So in this case, and it found a bunch of different planets, some of which are likely not supporting life. This one here doesn't support life. This one doesn't support life. But in this case, I found one that has a 22% chance of sort of biogenic life. Now, when I say 22%, 22% in this particular data set, I looked at 5 million potential planets. And so 22% likelihood out of a galaxy or universe of planets is actually really, really high. Like I don't know if you could probably get much higher than that without actually going and visiting the damn planet. But what this is looking at is sort of saying, what the molecular signals, it might be a little small, and I apologize. I probably need to up the font size a little bit here. But this is looking at basically found CH4 and 95%. It found some other sort of habitability requirements, and then it's looking at whether it's confirmation that someone other than me actually found this planet as well. And right here, it was found in 2023 by these folks, which I'm not going to try to pronounce. And it's telling me the various settings, so that's kind of cool. And this is all happening quite quickly. Now, once I've got that, I'm like, okay, how can I take this even further? Well, the next step is basically, well, actually, I didn't run the discovery pipeline. Let's run that for a moment. So this is the discovery pipeline running Rust in the RBF format. You can see how fast it is. And then, found something here. So I'm visualizing the orbit of the planet and it's telling you the radius. I can switch and you can see different planets have different sort of speeds. So you can see that this one's moving quite a bit faster. I'm just messing around with a self-contained file that includes its own AI, its own reasoning, its own understanding, its own vectors, its own all in that one file. And this is all running, in I think the entire thing is like 3 MB or something. So lastly, there was some research that came out recently, I think in the last month, that said that they've discovered some Dyson spheres. And I'm like, okay, let's take a look at Dyson spheres. So for those who don't know what Dyson spheres are, let's run the search pipeline. I can blind test it. So first of all, I needed to do another blind test. So the blind test is like, can I discover the same things that those guys at I think it was SETI found around these potential candidates for Dyson spheres that exist. Now, for those who don't know what Dyson sphere is, a Dyson sphere is this concept that essentially will wrap an entire star with this geometric structure that basically takes all the energy of the star and repurposes it. So what we're looking for in a Dyson sphere is basically places in various galaxies that have a kind of void, right? So you're looking at this void where you might have a kind of anomalous structure that says, well, there should be a star here based on gravitation and other sort of characteristics, but there isn't one, right? So in this case, I'm looking for the absence of the thing in which I'm looking for, which is perfectly suited for my min cut diagram. All right, so I was able to again do a blind taste test. This isn't food, but blind test, and I found Pepsi. And then what we have is I was able to find again the same results, 7 of 7 results. And then I'm like, okay, let's go find some more stuff. So in this case, what we're going to run, we're going to see what we can find that hasn't been discovered. And here we go. We're looking at again. We run here, and you guys can try this if you want to fool around with it. Ask Claude. Go to my Rue
Uh,
vector
Roof,
and run it. Yeah.
roof. One thing. So this is great, and I've been working on something which is tracking near Earth objects and interstellar objects in terms of artificial behavior and orbital mechanics. And I tried to model and build that in Python. I linked that to you in the chat. So if you maybe want to look a little bit, let's say, closer to our home, I've
I
noticed.
can't I
Yeah,
can't really talk about that. One of my clients one of my projects is a suborbital management system for management of near Earth objects, mostly space junk and satellites. So I kind of have to steer clear of that discussion at the moment, but
i-
it's the same tech. I've just
so maybe,
I applied what I'm doing for finding and controlling sort of suborbital or orbital satellites. And rather than showing you guys what I was doing in that space, I applied it more broadly. But it's the same tech.
yeah.
But
So
I can't really get into that right now. I've got
you don't
NDAs.
have to. I just want to pitch some inspiration. So bottom line, I've been noticing some, let's say, anomalous behavior in near Earth objects, which seem to be different than orbital normal mechanics imply. And I was trying to sieve through them and find out if they have certain patterns of behavior in terms of recurring presence in Earth, while trying to disprove the Fermi paradox. So if you have a look into that repo, maybe it's something that might help you achieve whatever you're doing without going into detail what you're
Yeah,
doing.
yeah,
Yeah,
for sure.
yeah, would
You
be
had
great.
me until Python. Make it Rust, and I'm your guy. But it definitely sounds interesting.
I don't have the
Um,
time and the token. That's the thing.
so the last part that I want to show you guys is the self-learning solver, and this is my most recent addition to my system. Now, the self-learning solver essentially creates a kind of, I don't want to call it AGI because that opens up a can of worms to what the hell's AGI. But essentially, it's a system that allows it to question its own structure, basically creating its own puzzles. So when you look at the configuration of the training, it's self-reinforcement learning in the most basic sense, but it's a self-reinforcement learning that allows the system to question and then form its own sort of causal loops of puzzles that it needs to answer. So when you look at sort of, again, I need to zoom in a little bit. You guys can run this if you want. But you look at the puzzles, I can define how many puzzles it's going to do, how it auto trains each round. Now, I use this kind of auto training, auto kind of puzzle solving system for just about any problem I'm looking to solve, like DNA or whatever it happens to be. And you can sort of play with the settings. I can choose balanced or various other components. And this is looking for sort of mechanisms to discover the undiscovered by telling back to the blind test. How do I find things that I want to discover without telling it the answer to what it needs to discover? Right? And this in particular is how I'm handling that. It's creating that loop, that really quick loop of the ability for it to learn very quickly through sublinear processes. So what that means, and I'm going to try to explain it because I'm on the verge of what even makes sense to me, but basically it's learning in very, very tightly constrained time-based loops. So again, microseconds and below. And then as it goes through that, it's creating multiple sort of parallel tracks that it can then test each of those potential or hypothesis of what those tracks may look like, different planets, different, elements, different things that it needs to understand. And it does that in a kind of parallel, or SIMD, I think is the actual tech. So all at once across multiple channels, and then they converge. At some point, there's similarities between all these different parallel tracks, and the system's tracking that kind of convergence of where and how those things are kind of blending together. And at which point it says, okay, out of a million or a billion different possibilities, these ones are clustering together in this kind of vector space, which you're kind of looking at here. And we see some of the data in the background, which is kind of a cool visualization of it here. The data, and this is sort of doing the pattern recognition. So obviously the red bits here are the parts that are less interesting. The green bits are the parts where they sort of cluster together. I know it's kind of weird to see here, but I kind of like the visuals. So if you're looking to apply this to other things like business or stock trading, you could literally take this entire thing that I built, point it at my neuro trading system, and say, go find me the best, stocks. But it's not finding those stocks based on the obvious patterns. It's finding it on the inverse patterns of what it thinks it needs to find, setting puzzles, and then saying, how can I solve this problem without asking for help? Again, kind of nuts. Um, Here's my memory system. So this entire thing is in about 9 MB of sort of total storage. This is how much I'm using. Here's my bounds for this will be min cut. This defines the boundaries of the system. Now I can download this entire thing as an exe executable. So if I want to run this and give this to someone else, I can just download the .exe, or I want to run it on my Mac, DMG or Linux, the tarball. The entire thing is completely self-contained, which is again the part that's most amazing to me. I don't need an operating system, literally running this whole thing on a single device, right? So when I jump back and show you the cognitive system, I'm doing the same thing here. Now, the difference is when you go into, let's say, it mounts it as both a storage system and as a network on your device. So the network would be the 169. My kids said I should have done 167, but I did 169, whatever. I thought the 69 kind of fit into each other, kind of like whatever. But anyway, so you get this launch. So on a Mac, you'd see this when you plug in the device, and if you drag this in here, it's going to do a quick lookup. It was so fast you probably couldn't see it, but it's checking the configuration. Then it takes you back. Now, if you go to the index page, you're going to see just the API. You can test the API at any point. This is the response, and it's super fast because there's no network. I'm literally connecting to the box, so I'm limited. The only speed is the speed of the time it takes me to traverse the USB cable, and to speed it up, I just used a shorter USB cable, which is the most amazing part. So the difference, I'm able to see the difference in speed between a long ass USB cable, this one being fairly long, and this one. So that's actually a measurement of I guess the speed of electricity. Maybe it's not light, but anyway, so the length of the cord actually shaved micro milliseconds off, but I could measure that, which was kind of cool. But when you go in here, you can see like identity, and I can test it.
Depends on the
We've
USB
got
protocol you're using. USB 2 or USB-C. Vastly different
I'm using
bandwidth.
I'm using USB 3,
That's
I think
just
is what
for
I'm using.
speed. The other thing to consider is how many retries are there over the longer cable, because the expectation is there's some signal degradation until the handshake is reestablished.
I'm not using Handshake. Remember, I'm using Quick.
Right,
So
but you're using the USB protocol, right?
No, I'm using and I'm using the MDNS protocol. So
Okay.
that's a network I'm not
How is
using
it
the USB
converted to a
protocol.
USB driver? Because you're
Well,
not
that I
running
did.
TCP/IP
That I'm
over
using a mount.
USB, right?
Yeah, so I'm only using the USB mount for sort of the initial configuration. As soon as this is configured, I'm actually bypassing USB altogether and using in this case, I'm using a Wi-Fi connection, which was faster than the USB connection in this scenario because it's so close, I guess. I don't know.
But you're
So
still running through the controller, right? Because the signal's still passing over the wire through the port, through the USB controller, over to the CPU.
No, it isn't. It's using in this case it's using the it's using my network adapter. In this case, I can hypothetically, I guess, use the USB controller for that. In this example I'm showing you right at the moment, I bypass the USB and I'm using Wi-Fi. Now I can mix and match, but regardless, it's freaking fast is the idea. And you can see it when I go here and do like a vector lookup, right? The response is almost instantaneous. Right. So it's and these are all the different API sensors. So for in this particular group you're looking at here, these are all my sensors that I might add for again connecting other things to it. And again, to Jed's point, the limit to speed is going to be the mechanism in which I'm connected to the device. So ultimately, I'm connecting a wire to these pins, and I can only move beyond. I can't move faster than the speed of the wire or the USB 3 or Wi-Fi or whatever I'm using. But regardless, it's way faster than any cloud by many orders of magnitude. So in this case here, you can look at my sensor drift history. So the drift history in this particular scenario would be looking at whether the sensor fits within the sort of a learned pattern of the sensor in which I'm looking at. So that could be, let's say, a heartbeat. And let's say this is in a hospital. Now, remember, this doesn't require any external network, no clouds. It all runs completely on this device. So that means it can learn in proximity to the patient in which it's connected to. So worst case scenario, let's say the hospital loses its interconnection, the power goes off. This thing's running on a thermal optimized processor that I devised. So it can run on, again, a AA battery or less. Now, if we want to see how that works, which is pretty interesting, here's all the mechanisms I have for overclocking the system. So I can adjust the frequency of the actual ARM chip based on whether it's doing something or isn't doing something, whether it needs more capacity or doesn't need capacity. And I can overclock this entire chip on this little thing, all 4 cores, up to 30% before it degrades to a point where it's unusable. But for certain things, like when I want to rebuild an index for, let's say, a GNN, I can overclock it just long enough to get that job done. So what takes potentially 1 millisecond at 1,000 megahertz can now happen at 1.3 thousand megahertz, and that shaves 30% potentially off the time it takes you to do that thing. So I'm going from 1 millisecond to microseconds just for that
Aren't you still
particular thing.
bound? A millisecond to microsecond is order of 1,000, right?
1,000.
So
It's 1,000.
how does a
Yeah, so
30% increase in something
I'm
produce 1,000% effect in something else?
Well, I'm already on the verge of a microsecond and millisecond, so it's enough to shave that sort of. I'm like 0.001 milliseconds or whatever. So the 30% was enough to drop it under that threshold, which is the important part.
So it's
But
literally,
it's a 30%. So 30% only is going to take you to so far. It's not like
So-
30x or anything.
so you're literally doing task-based clocking of your hardware.
Mm-hmm. Exactly what I'm doing.
0.001 millisecond is 1 microsecond already.
You can play with it. Anyway, so yeah, so what you're seeing here, in essence, is the kind of underlying pattern that exists within what I was showing you here. The only difference is this is the final app, right? This is the final result. But you can see how it's nice and quick. I'm using in this case 3JS for my processor on my laptop in the GPU, offloading that. But the actual intelligence of the entire thing that you see here is all power based on the device that I'm showing you here, or in this or where so I can run any of these on this. So in this case, if I want to take it further, let's say I want to download some of my other RVF related components. I've got the ability to let's go here RVF import and export. So I can then import my various, I'm not going to do it because I don't have it handy, but all I need to do is import my data.rvf that I stored, and then I can bring it onto the device. Again, it's a limited size in terms of the device. So you're going to watch out for RAM and you're going to watch out for the amount of storage. I've got 16 gigs in here, which is pretty good for most of the things I'm doing. But if you want to export it, then you've got the ability to go here and you can export the RVF as well. So it'll build it, and I get different formats here that I can choose from. So I've got, here's my security components. So everyone's like, okay, you built this crazy thing. Like, what are you going to do with it? So I know my most obvious example was the crazy example here of the universe itself, but it actually was useful because it represented a whole variety of things that most deep analytics is going to want to do anyway. It's representing the data in a higher dimensional structure in terms of the vector environment. It's representing it in a kind of causal relationship. Is it learning? Is it adapting? Is it getting better? It's defining drift. Like, is it going outside the bounds of an acceptable structure? Can it understand what that structure is? All this stuff here is happening within this system. So taking this and applying it to some other, like a legal platform or what Rob mentioned in terms of like group of satellites is at this point fairly trivial. It's the same basic structure and information, just with different purpose. So that's what I'm really trying to show here. Let me pause for a moment. I think you asked in regards the question in regards to how I was learning. Let's see if I can find. Did I get an answer to that? Let's take a look here.
I think Stuart had a question.
Sure.
Hey, obviously this stuff is really cool. If we were to take it from outer space and bring it into a business context, I'm having a little bit of a hard time wrapping my brain around how it applies, what it looks like. And have you done this in any of your business clients that you could at least describe what it looks like when you apply it to a concept that's more approachable for many of us who are kind of in that world?
Yeah, the most obvious would be the work I'm doing in the medical space.
Okay.
So the ability to sort of understand sort of the interconnected relationship of diagnostics within a hospital setting is
Mm-hmm.
one of the projects I'm working on. Mapping all the sort of information in terms of all the interactions, for example, between the current state of the patient's vital signs, medical history, pharmaceutical sort of interactions, and then providing the mechanism to traverse all that and say, based on all these things, here's what the likely X is, right? So, and I can do that really quickly. So that's like diagnostics, right? Just on a person. Another
And do you
project.
then, all right, but you do that with an RVF. Do you teach the RVF about the domain? Do you store the
Well,
AI and the data? And I guess I'm trying to understand how much is stored in the RVF and how much is the RVF acting on a data set?
it is the data set. It's all in the same file. There is no external. I bring it all into the one data set. There's no external. There's not like I'm going and calling an API somewhere else. I'm importing all of it into a single file. It all self-contained in one place. That said, I only invented this 2 weeks ago, guys. Like, I don't know. The world doesn't move as fast as I do. So most of the things that I'm doing in terms of the larger projects that I'm involved with are more traditional root, if that's even a thing, more traditional root vector, where I'm basically taking a lot of the things I'm showing you right now and I'm connecting to an API or a data lake or some repository of documents and whatnot, and then doing this kind of causal sort of analysis of it. I just took it a step further and said, okay, rather than having a whole bunch of separate systems in all these different places and all these different clouds and APIs, can I put that all in one package? But that's only 2 weeks old. So,
Understood. And then what's the limit of how much you can compress a universe into this kind of black hole sphere of an RVF that is omniscient? How much can you get in there? I mean, if you're talking a whole
a
hospital
lot.
system.
A lot, 96% compression. So I use the same sort of compression algorithm I use for like compressing an LLM,
Okay.
quantitizing, I guess would be the right term. And generally speaking, that in more traditional terms is 8 or 4 bit integers. I've settled on a 7-bit integer, which people tell me is odd, but it works really well because it's 1 in 7 is a prime number. It's naturally gives me sort of the benefits of being an odd number and a prime number. So I like it for my quantization, but that gives me, depending on the type of data and the level of which I need to quantize it, remember stripping out all the stuff I don't need and only focusing on the things I do, that generally gives me somewhere between 80 to a 90% reduction in the overall size of the data. Going beyond that, as the thing operates, and keep in mind, I'm doing millions and millions of little tiny calculations, which if stored in just plain text would be gigabytes very quickly. So I'm only storing the important deltas. The deltas are tiny, and those are hashed using cryptography. So super small little deltas that are represented in a vector space that I then can traverse and ask, what does it all mean, and how does it work? And
Okay.
that allows me to run it in on a tiny little chip kind of thing.
All right.
This
Thank
is
you.
this
I
this
mean, it's
isn't.
amazing. We're just trying to figure out how to get our head around it and how to apply
I
it.
can't even get my head around it. I don't know. I like this. To be honest, this is beyond my comprehension for most things. But it seems to work. So I don't know. All right.
So Ruth,
So
can you guide a little bit the commands to effectively create the RVF? So
ask
how do
Claude.
you do it?
Ask Claude. Just
Yeah,
ask Claude. Yeah. You could add no one's going to type in a bunch of commands. Like if you are, you've got more time on your hands than I do. Ask
yeah,
Claude. And I
yeah.
built it into my Agent DB. I published that this weekend, and my Claude Flow will have it here shortly. So the entire Claude Flow system was moving from SQLite to my RVF format. But basically, the most important part of it is it uses a copy on write structure. The copy on write structure means if you're familiar with sort of virtualization, if you look at like the WSL in Windows, which is the Windows subsystem, you have to partition that space, and then the maximum it can grow is within that structure of the partition. A copy on write structure allows it to sort of sequentially grow, kind of like a zip file, right? The zip file gets bigger the more stuff you put in it, but unlike a zip file, I've included a runtime kernel and the all the other root vector stuff in as different parts or layers within that binary structure. So think of each layer doing different parts of the requirements of that file. One might be, again, the Linux kernel, the other might be the GNN, the other might be a self-learning loop. Those are all different layers within the file. Some things need to expand, so there might be a POSIX style storage area, like what I was showing you earlier in terms of the USB drive, that might need to expand and have more space. That can grow, but it can also optimize itself. So because it's self-optimizing, I can then strip out any extraneous information to keep it tightly bounded. Now, again, I don't. You got to ask Claude if you want something a little more simple in terms of explanation. But the moral of the story is it's portable and it's deterministic. That means you're going to get the exact same result if you run my RVF in some other environment, in some other chipset. It's going to give you the same exact results, right? Where an LLM, even if you set the probabilism to 0, the temperature, the top K, the top P, you're always getting a bit of drift because it's always going to try to give you a bit of a probabilistic answer. So it's really difficult to get the exact same result every time. And you'll notice that with like, the additional adjectives thrown in here or there, the and a, that, and the other thing. And it's even worse when you start using mathematics. There's no room for drift in mathematics, right? It's inherently deterministic. So as soon as you start trying to say, well, tell me the drug interaction or the folding patterns of a protein, language models just don't cut it. You can't you create a probabilistic description of the protein patterns of a drug interaction. It just doesn't work. This solves that problem. It's explicit, it's indeterministic. So legal, if you need a witness chain, it solves that problem, right? You've got a sensor that's running in a black box on a drone or a plane. It's giving you exactly every single particular step that happened, and it's repeatable and traceable, which is important. All right, I'm blabbing here. Hopefully you guys can see my other screen.
You're not. This stuff's really important, and this is the stuff that helps
Yeah.
us get our head around what you're building and how we can actually find a way to utilize it. So this extra explanation is really, really helpful.
Agreed.
Yeah. And again, I don't have all the answers, guys. I'm,
We get it.
exploring and learning and trying to explain it the best I can. But some of these is beyond my ability to explain. All right. So Jed had a question earlier, which is interesting. He asked, how we handle decentralized state across multiple instances of root vector. This project has a layered distribution state designed to spread across several dedicated crates, which is kind of what I said. So we've got this idea of delta consensus. This is, and we might want to dig into that slightly more here in a minute. We've got this idea of a consensus algorithm, this raft approach, which I mentioned. This provides the state machine election log replication and quorum, similar to what you'd have in I think it's like Ethereum, probably. Then you've got this idea of a DAG consensus. A DAG consensus would be, if you're familiar with the blockchain world, this would be Avalanche, where so if Raft is Ethereum, DAG is again, it would be like an IPFS or a an Avalanche style sort of blockchain. It's not a blockchain in the way that Bitcoin blockchain, but for lack of a better term, it's similar. Then we get this idea of event sourcing, so this delta stream with checkpoints, relay, and compaction. So again, the delta, back to the delta. The delta is the vertical, the intersection, right? It's the state of knowing and understanding applied to itself. Sometimes described as that triangle icon from Greek, if you're in the Greek sort of alphabet. Causal delivery, vector clocks, and sharding. So this is my clustering capabilities. So this is how I would handle scaling this on a project that has hundreds of millions of users. Right now, my largest project, it has 100 million active monthly users. Shout out to these guys. Thanks for hiring me. But how do I handle that? So that's how I handle that. I'm handling that through a combination of the clustering and the replication to allow for a kind of eventual consistency in the system. Conflict resolution, how it all fits together. State flow. So now I asked it to explain this in a simpler terms. All right, let's go for simple. So think of root vector like a team of people all working on the same giant spreadsheet, but each person has their own copy. So think of RBF as their own copy. So RBF is kind of like a PDF file for like cognition. So who has the data that's done in the form of a shard. So instead of every instance holding all the data, we split it into 64 chunks or shards. A consistent hash ring decides which instance owns which chunk. When a new instance joins, only a small slice of the data moves, not everything. Remember, I'm the anti-blockchain. I hate the concepts of having to move all the data for like consistency and understanding and sort of conflict resolution, which is what essentially Bitcoin and Ethereum do, right? They're like, if you want to be a node in Bitcoin, you got to move all the Bitcoin transactions that's ever happened, which is stupid and unnecessarily to prove the work. I don't have to do that. I only need the deltas that are needed to prove that particular part of the work. So we have two different strategies, as I was trying, but badly trying to describe earlier. So we've got a sort of raft consensus. One instance is elected leader, all rights go through it. So that I guess would be centralized if to Jed's point, and the majority must agree before anything is committed, like a team vote. So in that instance, it's kind of like Bitcoin, right? People claim Bitcoin's decentralized, but it sort of isn't really decentralized from a completely decentralized approach. Then we've got this kind of frequent, idea of using CRDTTs, special data structures that can be merged without conflicts, no matter what order the data arrives. That is sometimes referred to as eventual consistency. That back to my quick protocol, that means I don't need the data to be delivered all at once in a sequential pattern in order for me to start working on it, which is important because in the form of my RVF format, the entire package could be multiple gigabytes, but I only need the first 4 kilobytes before I can start working within the structure of the package itself. So it grows, but it can be worked on before it's done downloading. Just making sense, or I'm hoping this is
So
helpful.
for number 2, you have a centralized writer that acts as the canonical source of all the data. It doesn't necessarily store all the data. It's an index that points to the other nodes which carry the shards where the data actually lives. Did I get that?
Yeah, I think that's about a way to look at it. So
Okay. So in this raft leader thing, how does in the event the leader dies or is otherwise marked as, I think it was suspect was the term, how then is the new leader elected? Assume someone has it's elected amongst all these nodes, but all nodes do not know about each other. They only knew about each other because of the leader, right?
Yeah,
So
how's the system remain?
What prevents the system from creating a series of islands where,
Yeah,
let's say, adjacent nodes elect a leader, but then a different island of adjacent nodes elects a different leader? How do they reconcile between? Does that make sense? And for those listening along in the chat, let me know if I'm not making sense.
I doing a question I can ask. Let's go Jeopardy on this.
What
give me.
is okay? How do decentralized nodes with only knowledge of adjacent nodes elect a leader under Raft?
Type that into Zoom, and I'll pop it in here. But the moral of the story is I'm not using centralization, so it's not really about a required question. I'm decentralizing the thing. No, I'm using the decentralized protocol. I can use Raft if it's a trusted network, but as I showed before, it's generally not required, right? And that's why I'm using the consensus algorithms and whatnot, which are decentralized. So that's you have you've got different architectures you can apply. All right. Now, if it's an environment that you trust, sure, you can use a centralized approach. All right. How do we decentralize nodes? Who knows presence? Okay, that's a good. Let's see what it says.
Which repo is this in? And maybe I'm querying the wrong one.
This is RooVector. So yeah, this is my RooVector, and there's millions of lines of code in here at this point, so you need to kind of point it in the right direction. All right, so what do we got here? Leader election when you only know your neighbors. Gossip first, vote second. A node can't vote for someone it doesn't know exists, so it happens in 2 phases. Every node starts knowing just a few seed peers. Then A knows B and C, and B knows A and D, and C knows. So it's a hierarchical grid. It's the most fundamental part of my swarm structure, right? You've got it's in this scenario, and it's a hierarchical grid. So what you're really talking about is what happens if, how do we handle fault tolerance? Phase 2 raft. Okay. How do we handle fault tolerance in a decentralized form? Something like that. I think you just got to ask Claude, to be honest. Fool around with it. See what you can what you can cook
Are
up with
there
it.
any uncommitted changes here? Because I'm cloning the repo shortly, so I can ask.
No, I just did a push this morning. I did a major update actually. Speaking of, there's a couple new crates that this is probably right up Stu's alley that might be really interesting for you. In particular, I created several novel new forms of no, that's not Node. I want to show you. I want to show you the no transformer. Yeah, graph transformer. Sorry, a lot of stuff to cover here. I've been on a bit of an epic swing here. So what I did here, I created several new graph transformers. So what this does is lets you create mathematically proven sort of elements that it can then be applied and understood using a sort of attention mechanism. If you're looking to sort of push into the further into the boundaries of really large amounts of information, like how do you scale to millions of nodes and understand the sort of physics of those nodes. So let's say you're doing drug analysis and there's billions of particular nodes, and understanding the causal effect of how those are going to affect, people and other structures in and around it. This library is going to handle that sort of thing for you. If you just got a ton of information, let's say you're Google and you have the entire internet that you need to look at, this structure would allow you to traverse all that. So this is the structure for like super large data sets, billions and petabytes of data, and then being able to traverse that really quickly. So I've got a few different modules that I've created for that. Sublinear attention, which is probably the most interesting. The proof gated one, let's see. This provides the ability to validate each element within the actual graph state before it makes a decision, which basically means it's deciding on the decision before it makes the reasoning process that it needs to reason on, and then reasons on that reasoning. And that's happening in using a sublinear attention back to speed, really, really tightly constrained time frame. But if you're looking at sort of going down the rabbit hole of crazy, this is the one to look at. And I include all the various ADRs to show you how I built it. So if you go in here and you look at the ADRs, you can here's the this is probably the most interesting for me. This ADR basically graphs sort of real world dynamics. Well, why is it rendering for me? Anyway, the real world dynamics would be like a world model, like from the particle level on up. So I can map the particles of a system using a simulated quantum state, which is what you'd see in that example I was giving you earlier, and then apply attention to it. So this is again absolutely insane, but the practical application was that planetary system that I was showing you.
Roof, have you tried Falcor DB? Have you checked it out?
No,
It's
what is it?
pointed to your swarm. There might be a couple of things that are interesting because they're actually
Let's
using
do
main
it.
operations when they're doing the queries instead of Cipher.
Yeah, let's do it. Okay. Let's create. I'm on main. Let's not work on main. So let's go here. Create new. I'm BSP. And I gotta update my Claude code here, but whatever. There was a major update they did to Windows the other day that broke everything on Windows. New branch and review doc research. File core. I like the name. File core DB. All right. Let's
Yeah.
see what what's it built in.
Really interesting and faster.
Falcor DB.
I have a question.
Sure.
When you mentioned that amount of data that you were saying before in the project that you were mentioning before, or in the package, to handle that amount of data, you mentioned that RBF format will pack all that data in one file.
Yeah,
in a very small file to run anywhere.
I got this so small that I was able to create a seed and put it in a QR code. That's how small I was able to get it. So you can literally embed the core intelligence of the RBF cognitive system in the space, which is 2,000 bytes. So I guess that's two kilobytes in a QR code. So when you scan the QR code, then the seed then expands because it expands to available information to it. So the most basic could be like a QR code that then opens up in a browser, possibly, or whatever. And then once it's in the browser, it expands and downloads and optimizes itself based on that. So it's literally, I don't know if anyone else has figured out how to put a legitimate AI inside a QR code, but yeah, that's how small you can get it.
I mean, all you need is a large enough camera resolution to interpret the QR code, right?
Well, the QR code is limited, right? You can only put so much information in. I think it's like 2,000 bytes. So, but I was able to get it into 2000 bytes is the moral story, which is tiny. Now it's gonna download it's gonna download other stuff at that point. Like I could do some basic stuff in 2000 bytes, but really if I want to do anything particularly interesting, I'm gonna have to bring other systems in the play at that point. Now, the only thing I don't like about this Falcor thing is Redis. Like, why do I need Redis? It looks like you need to run it in a Docker. It's
Yeah,
Python.
the
Looks
matrix
bloated and
application is
looks
saying
like
interesting thing when doing the queries, right? Maybe if you're able to
yeah,
extract the logic and then apply it somewhere, it'd be really cool.
it's using sparse matrix. I'm doing the same thing. It just looks like a bloated version of what I'm already doing. I'm using sublinear algebra for queries. They're using linear. Yeah, it's similar in structure to what I'm doing, just slow and bloated.
There you go.
Yeah,
When you
yeah.
when you create the cognitive container, you're using Firecracker, right?
I can. I don't need to. Firecracker is a I guess an orchestrator for bare metal. So you know you can use it if you want to use it on like an E2B style environment or like a serverless environment. Then you would use Firecracker. Now for like on my ESP32 or whatever, I'm just compiling the RBF directly to run on the ESP32 or an ARM-based processor, and that I don't need Firecracker.
As a
It'll just
binary.
yeah, it's binary. Now you're gonna have to compile it, right? So remember I was showing you earlier this download? Yeah, when you go here to download, download as an exe or a DMG. So I'm compiling the RBF to be an exe. Right, and then no installation required. You can just double click the exe and it'll run CLI or desktop or whatever you want. No installation. Now, in that scenario, I'm compiling it for Windows or Mac. Right. So because it's Rust, I can compile it for different environments. Now, the core RBF itself is just a binary. So when I include it with a runtime, for example, when I've included in AgentDB as well as the MPX root vector, that includes the runtime. So I don't need to worry about compilation at that point. I can just run it through the npm runtime. So it'll just work, right? Because I've already handled that part of that problem. But if you don't want to use an npm, you want to just have it native, on the chip, bare metal, then you just compile it for that chip.
Got it.
Let's see. I've got the other one running too. Let's see what it has to say. It's almost done. Let's go back to the other screen. Too many monitors here to keep track of. Agent is complete. I got a file somewhere. No, it's not quite done yet. And by the way, if you're curious about how I build everything in root vector in particular, which is kind of my lab, you're going to see the various ADRs. And the ADRs again is kind of the magic to how I can build all this stuff. Oops. Research Falcor DB. Okay, let's go there and see what we can see. Research Falcor DB. All right. It's not rendering that for a moment. I got to restart the VS Code. You're gonna have to look at it in so Falcor DB is a high performance in memory property graph based on Redis, which is or Redis graph. It's got a shitty license. It's got lots of stars. It's an architecture built on a single foundation. Graph traversal can be expressed as sparse matrix multiplications. So yeah, same premise. I've got the same premise, generally speaking, of this idea of sparse matrix. Rather than crawling through, Falcor translates cipher patterns into algebraic expressions by graph BLAS, topology, data model. Okay, let's ask stupid questions like how's it better or different than how's it better or different than root vector? That's the real question I want to ask. And I'll take whatever's better and we'll integrate it. I'm going to go full Claude code on Falcor.
And keep sharing the ADRs. This is very important, I think, for
I'm going to create an ADR on this in a second. So what I'm going to do is I'm going to take the best bits of Falcor DB and I'm going to create a, I don't know, an RVF and then we'll go ahead and do that.
I have a question, Roof. So for the you were showing the API earlier on for Cognitum, and where is that in RuVector in the repo? Where is that?
Sorry, wait, you're talking about how I built the causal. What are you referring to?
The Cognitum API, right?
Oh, I'm that's my box. You're gonna have to buy one of my boxes.
Yeah,
it's
no,
not
I
available
get
yet.
that. I know, I get that, but where's the documentation for it?
On the box, on the device.
Okay,
It's
so
you plug in the device and it shows up and as on in your browser or wherever
there's
you
no
want it.
documentation now to look at it to see what to build on it.
Well, it's between us. It's RuVector. It's just a
It's in
commercial
RuVector.
version.
Oh, I see. Okay.
It's a commercial version of it with a dashboard and a bunch of other stuff. You know, and some people don't like CLIs, and for those people, I've got a dashboard and whatnot.
Right.
All right. Okay, so according to this, Falcor DB and versus RuVector, they're fundamentally different things. Falcor is a database, RuVector is a computation engine. They solve different problems at different layers of the stack. Falcor DB, graph database, storage, and queries. I don't know if I'd agree with that. They're building it in C. I'm building it Rust. They're doing stores. I compute over graphs. Falcor is better persistent graph storage. Well, I would disagree with that. I've got persistence. Okay, Claude, you're letting me down. Okay. What about the root vector, Postgre and persistence capabilities? That's the problem with my repo. It's a bit too big for even this thing to understand.
It keeps forgetting about those. Yeah.
Yeah. So GraphRag SDK, turnkey LLM integration, no graph aware RAG. Well, yes, I do. I just showed you the graph aware RAG. It doesn't.
It's built isn't built in ROS using REDB, right? So that's why it might not be able to read through it.
It says it's complementary, not competitive. Okay. It's a Redis module. I think the system doesn't. I think in this particular scenario, it doesn't quite understand what I'm doing to a point to give it because everything it said here isn't actually true. A lot of it's not true. Like at least in terms of my capabilities.
Have you built an RVF on RVF, Roof, so that it understands everything it is, can do, etc., in a way that Claude Opus doesn't keep getting confused?
Yeah, I did. There's where the heck did I put that? You're talking about like an NPM module? RVF. Yeah, you can hear all the RVF components. Yeah, I can't. It's not rendering for some reason. I'm not sure what happened to my VS Code, but this is the document. This is what you need to point it at. And it's published. I published both as a npm and a crate, so you could run it in like Cowork or whatever in Claude, that kind of thing.
I would like to make a note here, Roof, if you allow me.
Sure.
I think this is exactly what will happen most of the time. Whoever is trying to wire something that you already built, Claude is not smart enough to understand how to do it, or still missing a lot of the implementation that you already have. So I have to go push and push and push and finally understand what is actually implemented. So my idea was that we have an MCP with all the projects, with all the documentation, all indexed correctly. So we don't have to keep pushing, just to have a
Oh,
roof MCP
you're talking.
with
I think you're talking
everything.
about. Yeah, I think you're talking about my Ruby MCP.
Yeah, but I don't know if
I
Ruby is actually with every single package.
No, I
So
haven't got around to doing it. I get too much crap. I don't
I
know.
know, I
It's
know, I know. So my plan was to take Ruby and actually create a full updated for all the packages. So, and include it in Cloud Code. So every time it will be able to go in the MCP, find the technology that we have available, and not try to reinvent it. And then it come back and say, okay, I can use this, and this, wire it, and we have the solution. This will be the most useful for everybody trying to use
well,
all the packages.
to get going, Ruby is probably a good place to start. I built so much crap, this is already out of date, but you can
Yeah.
tell here there's 250 packages. I'm well into like 1,000. So I would need to add another 700 probably. But this is probably a good starting point. It's organized by structure. There's an MCP for all of it. You can interact with it. It's MPX Ruby. You can see there's just a lot of stuff in here.
And,
Well, I don't know. I don't know if my idea was good or bad. It just pushing ideas here.
It's a good
Jose,
idea.
that's what I tried to do with the Ask Roof. Now I just put it in the chat if anybody wants it. It literally goes out every night, looks at 148 repos from Roov, takes down all the latest stuff, stores it in Roov Vector. I created a knowledge base and an MCP against that. I've made available for you guys if it's useful. I'm still trying to get my head around it myself to try to do just that because I think a lot of us are struggling with how do we make sure that Claude is smart enough to understand what Roov is doing. And so I've got it looking on a daily basis. If you click on the knowledge base and the knowledge universe, it'll show you on the left kind of what's been updated, what the latest repos are, things like that, just to kind of give a flavor for some of that stuff. Whether or not it's all the right answers, I don't know. I've been really just trying to get it to get its head around all things Roov because I think honestly we all have a challenge kind of keeping up with that rate of change. And we really have a frustration with Claude being a couple, 3 or 4 hops behind. And I, like Jose, have to spend lots of time trying to catch it up on the advanced concepts you do every day.
Stuart, if I may offer some feedback,
Of
add
course.
also the GitHub commits, not just the repo contents, because Claude is usually good about leaving notes within the commits of what was intended, and that can be reconciled against the actual pushed code.
Yep. Ruv, if you click on the button on the left that says knowledge base or the knowledge universe, right, that'll start to tell you kind of what's there, the latest, how soon it was updated. I've got it sweeping on a nightly basis, kind of pulling things down to read and pull in. And if anything's new, if there's a new rev, it starts running those. At least that was the intention. And it's all kind of built with the latest and greatest, but who knows if it's the right thing. I think in an hour you could do the stuff with it that would turn it into something that would deliver that. And if you click on the knowledge universe, I'm trying to get it to yeah, if you click on the ball in the middle.
That's cool. That's
And then
awesome.
each one of those allows you to traverse up and down the path to see what are we learning, what's there, how do we dive into it, up 3 or 4 or 5, 6 layers and levels, because I can't figure out what the hell's in a root vector. I know everything is, but so I'm building this to try to understand what do we do, where should we use it, why should we use it, what are the advanced techniques, and how could we explain to Claude Code, even if it's Claude Code at v3, how does it know some of the other crazy, as you say, that's in root vector that it can and should be using to dynamically or novelly solve the problem you're asking it to work on?
Yeah.
Right approach, wrong approach, Rube, you would know, we wouldn't.
I'm just experimenting. Like you're seeing the output of my experimentation.
Sure.
I'm just trying to see where the rabbit hole leads. I
Right.
think that what you're doing is visualizing it in a way that's useful. And we should package this whole thing up as an RBF.
Take it.
And if you
Listen,
package this,
you contribute all your stuff. If this is in any way useful, please take it, roll with it.
let's add it to my Ruby package and then package that up as an RBF. and then you can just basically point it at that. This is cool. This
Can
is
I
really
you?
would
cool.
I
Can
would
you?
definitely use this thing, 100%.
Yeah.
Yeah.
I actually thank you, Stuart. I feel better now. I'm not alone in this situation. And then
We're
another
all
thing.
feeling this way, Jose, brother. Believe me.
Yes.
and another thing is just make it update automatically based on it will check all your repo and everything.
It
So you don't
does.
have
It happens on a nightly basis every single
correct.
repo.
Okay. Because I
And
have
it even
something.
looks for other new things he's done. Because Roof, I never know where the heck you're taking some of the new crazy that you're inventing just this week. Because
Question,
sometimes
Stuart.
they're in RubeNet and sometimes they're somewhere else that you're working on them.
Question,
Yeah.
if you don't mind,
Me-
Stuart. Based
Yes,
on Jeff's comment, I agree. It's very useful to include. I don't know if you're doing that. That's the question. The issues there to get the intent also. That really helps.
What was that? Sorry, I missed the question, George.
Yeah, in the GitHub you got issues, right? Based on
Yes.
those, you can find the intent on some packages, because otherwise Claude got lost in
I
missing
agree.
connection or wires
I
I
missing
kind
or
of
whatever.
kept this out of Claude. I just had it be Claudeflow v3 and Roof Vector build this so that because Claude gets confused too much dealing with Roof stuff.
Exactly.
Is that the right way to think about it, Roof? To have Claudeflow
Yeah.
v3 and Roof Vector be the two combined to go build it?
Well,
think-
yeah. There's a collection of stuff. If you want to think of like conceptually, my root vector is my lab. I just create and I put it out there. Then it trickles up into AgentDB and Agentic Flow. And there's two new versions I'm pushing out today of both those packages, which is more of a commercial sort of package of it. That's like, how do I use it in a business kind of packaging? And then
Right.
ultimately, once that's sort of, I know there's no major bugs in it, then I push that to Claude Flow. I'm in the process of doing the Claude Flow push, and that'll be Roof Flow here shortly. And
Good.
that's my stack. That's what I build. So if I need an agent that lives and breathes forever, then that's my Agentic Flow package. Like if I'm creating OpenClaw or whatever, that's how I would do it. I would use that package, and it's got everything basically. Those Agentic DB and Agentic Flow has everything worthwhile. I've stripped out the crazy. Some things are just so out there that you position it and people think you're insane, but it's positioned a little less insane, basically.
All right. Well, can I offer this to you, Rube? Is that useful at all? I'd be happy to invite you to the repo and you can take it and run with it however you wanted.
Yeah, send it over. And what I'll do is I'll package it up as an RVF and put it in Ruby.
Beautiful work, Stuart.
Yeah, it looks
Thanks,
awesome.
but look at it first to make sure it's what you want it to be. Me trying to deliver your stuff and you trying to deliver your stuff are two different things.
Yeah, I get it. There's so much stuff here, and Claude half the time thinks the stuff I've created is too crazy to even be true. But
And
then I'm
that's
like,
my
no,
concern.
it's true. Like you saw it here before. It's like, oh, your system is too crazy, right? Oh, no, it isn't. It actually works. So like here, I said, what was the root vector Postgre and persistent capabilities, and it says, oh, look, you've actually got a Postgre implement. Well, yeah, that's my core thing. Like you can run it all in Postgre. Like, come on. And then it says, add solvers, and it does, my embeddings and all that kind of stuff. And yeah, here's this is probably the most probably the most appropriate comparison. Nobody wants to use Redis. It sucks. I chose Postgre, and it can run in or outside of Postgre like SQLite. No near zero loss. It backs up. You got replication, consensus. If you're looking to build the state of the art in a business, I at least the businesses that I work with, it's got everything you need. And you just got to discover the pieces that you need, which is back to Stuart's component. Now, according to this,
and just to say something before we continue about the intervention from Jordi and Jet, I think it's very important for this kind of system for helping Claude that the intention of what is the package for. So the Git implementation are very important for him to know it, because I tried. I was working on this for a few weeks, but this implementation from Stuart is even better. But I think this is important, the intention of the package, so it will understand exactly what it's for. Sorry.
Yeah, that makes sense. The other thing that I might suggest you do if you're curious about exploring it, point it at my ADRs. Everything I've built over the last few months is an ADR, and they're all interconnected to one another. So you could basically create an index of the ADRs, which are inherently a kind of multi-dimensional structure, and then you can map it pretty quickly. Now, I haven't shared my personal Roo vector learnings, which maybe I should, but I'm just worried that I might expose stuff that I probably shouldn't. But if you look at my environment here, I've got 6 gigs of data that underpins my learnings. And this was a question I think Jed or someone asked earlier, like, how does it know what you've already built? It already knows everything I've built. I've got the master brain. So the reason I can build as quickly and as efficiently is because its system knows everything I've done to get to this point in the system. So I should probably export that so you guys can use that.
You've put that into root vector Postgre?
No, this is running just native. This is just running natively, and as I think it's an RBF at this point. Can we export all the learnings
So
of
it's 6 GB of text?
no vectors of the Claude Flow? What am I call it? Memory in a RVF format that others can use based on everything we've learned in this repo since the first day of its existence. I don't even know. Do deep review and create an ADR. I'm gonna say other users will use this to kickstart their Roo vector development journey. We're okay.
Well, I actually have one question about that memory recorded. Is that in some way able to lose it if we force installation of Cloudflow or anything else?
Possibly, but I've got if Cloudflow has checks. So when you do the init, it actually looks at your existing memory and then ports it to whatever crazy concocted scheme I've come up with. So it basically imports it. So remember the sort of when I first launched Cloudflow in June last year, it was a JSON, and I just did kind of appended JSON files, and there's some remnants of the JSON still in there for certain things that just JSON's fine. And then I moved to SQL. Then I realized that I had some issues with SQLite. Then I had some issues with cross-platform SQLite. So then I moved from using better SQL 3 to SQL.js, which was a WASM-based approach. Then you start seeing the memory.db files and the swarm.db and a few other files that created a binary. And then that was my sort of, oh, if they're doing a binary, maybe I could do a binary. Then that inspired me to create Roo vector. And then I'm like, oh, I can actually create a multi-layered binary. And now I'm in the process of replacing all the sort of SQLite binaries with my RBF style binaries. And then so in the updated version that you'll see some of it right now in AgentDB, and in probably an hour or two, you'll see it in Agentic Flow. But I migrate those binaries from SQLite into the RBF format. So I'm kind of moving it. Now, if you use the force option, the force option could potentially overwrite your claude.md and some of the other files that you have. So be careful with the force. There's an upgrade command. That's what I use. And there's upgrade settings. The upgrade settings will give you like the most recent status line component that you saw when I shared my screen a moment ago. I've optimized that a bit because Claude Code keeps mucking around with the status line, little dots popping up and that kind of crap. So
Yep.
I've had to do several updates to that based on their issues, not mine, but that's the path that I'm taking.
So that the 6 gigs right now is
I'm
before you
late.
convert it into RVF. What is it in right now?
Right now, it's in a SQLite form.
Okay.
Yeah. So what I'm going to do here, I'll publish this later today for you guys. What I'll do is I'll give you a kickstarted version of my memory, and then all you need to do is point Claude at my memory and say what the heck is in this thing, and that'll give you a vector graph memory structure of everything I've done to build everything in this particular repo.
Why
That's
is that
amazing. And
necessary?
we have
thought
to
you
give
could
it
use-
a link to the RVF crate as well, right?
I can, you know what I can do? I've got a runtime in RuVector and the MPX RuVector. I can make it available as part of my MPX runtime for you, and all you need to do is just execute the RuVector runtime, and it'll just import it and use it.
Why
Something
would
like that.
that be necessary? Couldn't QDAG just be used so everyone is federating off of your copy roof?
Yeah, I could do that too.
Spit it up.
I've already.
Ship it. Let's go.
Yeah, I've already. That's actually not a bad plan. If I do that,
Yeah.
then we could do a federated, model where I'm the,
Collective intelligence, right?
Exactly.
collective intelligence. And then anytime I do something crazy. Now, the only problem with that potentially, and I'll have to do some PII stripping and environmental variable stripping, which I already have. But other than that, yeah, I could use a central node on Google or something, which is probably good enough. And then you just activate the central learning component in maybe MPX root vector, and then you'll automatically get whatever I do.
Well,
as
it's
I do it.
bidirectional, right?
What?
So that other learnings can be fed into the memory.
Hive mind. It's a hive mind structure, maybe.
That would be great.
Yeah.
And then the expectation is everyone's node is functionally decentralized, and therefore they learn from each other or each other's learnings and append to their respective corpus in order to solve problems relative to that specific node.
Yeah.
Yes. But remember that I mentioned like last year about this proof, about sharing the knowledge. And you say that you implemented it in APF. The one that you have
IFPS.
for the plugin system. I think you have something already in place because I remember we talked about this sharing memory or sharing knowledge. Isn't it not already in place or something like that?
Yes, you're talking about my transfer learning. I've got it all. I just got to use the stuff we've already built. Yeah, the transfer learning component would also be a way to do it, and that's how I'm doing it in Claude Flow. There's the ability to export, and I think actually this might have been your idea in Claude Flow, the ability to export the Claude Flow learnings amongst different environments. So I've already built that.
Yes.
Correct. So that would be the best, I think, to start. I mean, if you want to share knowledge,
Yeah, there's certainly no shortage of ways we could handle it. But I think what you're suggesting is maybe there's a way for us to federate our knowledge and share it in basically real time.
I think the important part is to keep everything opt-in as opposed to opt-out. So make available for participants in the network to opt into the knowledge, but do not push the knowledge onto them. Make sense?
Yeah.
All right. So I think I hear what you're saying. I'm read only kind of thing. You're reading, but not necessarily writing. Well, I'm writing, you're reading.
I can read what you write. You can read what I write. I do not write into your space.
Correct. But actually,
the RuVector format actually has this kind of blockchain,
Yeah,
right?
yeah. It's already built in. Can we, so let's just update this particular so this is the initial RV, the spec. And all right. So where did I got too many things open? Where did I put it? Here? RVS knowledge. Yeah, here it is. I don't want it's doing for Falcon. I don't want Falcon DB. It's confused. Regardless, can we create a federated, an optional federated RVF format that allows real-time learning to be exported and shared with other users as I create new modules, crates, stripping any PII or V, but including the core learning. We can call that transfer learning. Using the Google. We should put that as Google Cloud. I'm just going to let it figure out what that should be. For this, I'm going to give it a little extra helping hand. I'm going to use the goal. No Falcon. What the heck we call it? No.
Falcon DB.
Yeah, I don't want Falcor DB. Create a new branch. Actually, I'm going to do create a branch at the beginning because it's
Roof. Sorry.
created RVR. Yeah, I'm late for my Lex call. I think I feel my phone buzzing. Create new federated RVF. Federated RVF. Start mission. All right, that's where I'm going. We're going to create a federated hybrid shared learning system using an RVF format. And then we're going to tie that into Stu's dashboard, and then I'm gonna include the GitHub synchronization. So any commits will auto populate. One shared brain to rule them all.
Wow.
That's perfect. I just made my repo public, and I invited you, Rube, specifically to do anything you want to it, to take it, change it, add it. I don't think I have Ruby in there. I think I just have the GitHub repos. So whatever else you want to add, and I didn't have it looking at the ADRs yet. So you're right. That's probably a great call.
Yeah, this is cool. So cool. Thank you. Thank you,
All
Rube.
right, sounds good, guys. I'm late, so sounds good. I'll talk to you guys later.
Later, guys.
Thank you.
Okay.
Yeah.
Bye.